Well, this is the start of my encoder that I'm going to put on the end of this thing. Now, these are the pieces that I came up with. So I'm going to attach a pulley here and another pulley here. So what I did was I ordered these pulleys. Ordered this pulley and this pulley. Those were identical. I mean, they are identical, except that I machined this one out. And I ordered the belt. And I ordered this needle bearing. Now, I didn't really need a needle bearing. Could use a bushing. But I ordered this from, what was it, SPD or something? Yeah, SDP. SDP. And you have to have a $30 minimum order. So these, the belts and the pulleys only came up to like 25 or 26 bucks. So I didn't want to spend 10 bucks extra. So I ordered the needle bearing, which was like 7 or something. I figured I could use it, even though, like I said, I could use just a standard bushing or make a bushing, but since I had to get the order up to $30, I went ahead and got the needle bearing. Figure it's better. So this is the parts I ordered. And I'll explain why I ordered these particular parts. Let me put you up here. So like I talked about before, it's going to make something to go on here. Now this could go this way or this way, it doesn't matter. But anyway, what I was going to do is going to have a pulley here, another pulley here, both the same, and then have the belt between them. So that when this one drives, this one rotates the same amount. So why I ordered these pulleys is because I wanted to keep it as small as possible. Now, the only thing I did was I ordered the same type of pulley as I have in the back, which is really wide. I probably could have went with a narrower one, but the thing is that I knew I could figure out this inner race, the pitch diameter, and that was important for when I do this, because I wanted to keep this as small as possible. So what I wanted to do is I wanted to mount it on this surface and this surface and use these existing threads to tighten it up. So what I was trying to achieve was that this diameter on the inner part of this pulley has to be a little bit smaller than what I had here, because I wanted to open that up just a little bit. And so I didn't want to go with too big a pulley or too small a pulley, because then I'd have to stick it out here further. I wanted to keep it as far back as I could. So this was the size that I could put on here and take a cut on here and recess that back. Now this diameter was too big, so I had to turn this diameter down. So I had to take that shaft out, and I had to turn this diameter. I left this one alone, and I left this one alone. No, I did. I think I did turn this. I turned that to the outside diameter of this thread, so that it would be the same diameter here and here, and I turned this one down. So let's see what we got here. I got 1 inch 880. One inch 876 here. That depends on how much you squeeze it. 1 inch 876. Then on this diameter, this is 1 inch 720. These threads are 1 inch 717. I didn't want to cut the threads, so I left them just a little bit above that. But when I got these pulleys, they were both the same part. Now, when you look at this pulley, you know, I thought, well, this is solid from here to here. I mean, that's what it looks like. So I wanted to open this up a little bit, so I took this down and I opened this up just a little bit, and then I come down, I set the depth so that, well, I had to open this up too to fit this. So when that goes on there, I was going to have it hit against that brass bushing, and that left me with this much gap, and that would be the gap of the plate that I would have on here. And what I ended up with was about 1/8 inch. So after I made the plate, it was kind of flimsy. So I said, well, that's not going to work. So I made it 1/4. That'll be a little stronger. Not that it needs a lot of strength. It really doesn't need much, because all it's doing is just rotating that. Then it's going to rotate the other one, and it's going to rotate a little magnet. So I really could have kept it at 1/8, but I just didn't want to. Because you know, thinner material, it tends to warp a little bit and this and that. So I wanted something a little thicker. But these pulleys, I was surprised because when I took my cut, it's hollow on the inside. You see, they got this back piece here, which is this. And if you look closer at it, you can see there's a gap in there, right in there, that this piece and this piece are not connected. I thought that was solid, but it's not. There's a gap in there. But nevertheless, I made that to fit this and to fit that. This piece fitting that thread portion, and then this diameter fitting that diameter. So I ended up kicking this out a little bit. So I made this little spacer. That goes in there. There. And I kicked it out a little bit. So now we're just a little bit over a quarter. It's probably about, not quite 312. It was probably about 280. Somewhere around there. So what happens is that when I first made this, it had to be adjustable. You know, this part, this pulley that goes on here had to be adjustable, because you got to slide it in to put the belt on, and then you got to slide it back out to get tension on the belt. So it had to be adjustable. So I made the distance from here to here 3 inches. I mean, you can make it anything you want, but I'm using 3 inches. And then using the center to center distance on this website, come up with this belt, and that worked out great. So what I did was I made this plate, and these silver things, those are helicoils. I put helicoils here because sometimes when you're putting threads in plastic, you know, sometimes they're tight and sometimes they're loose, and I needed a consistent tension on it. So when I snug it up, I know I'm there. If the thread's tight and you snug it up, it might not be tight all the way, but it seems tight because the thread is tight because of the plastic. So I did the same thing here too. I drilled a hole here for a set screw, and I put a helicoil in there so I could get a nice feel for it. So my idea was I made this, and then that would slide back and forth. You know, you slide it this way, you put the belt on, you slide it back this way, you tighten it down, and you basically never had to move it again. But the part that gets mounted to this is some type of square, I think it's like 7/8 square. And I don't have the part. I ordered the parts and I haven't gotten them yet. The only parts I got was this. But I thought about putting some type of, to mount a square plate on here, I was going to make a square and then have it fit on here and have some kind of clamp to where I could clamp it on here and I could move it in and out to get the adjustment just right. And I think what was happening was I was overdoing it. I was overcomplicating it. Because I have to make this piece, I have to make the other piece, then I got to make it fit on there and adjustable, and it was it was just too much. So what I ended up doing was I made this piece. That's why I have these 3 holes here for this piece, but I'm not using that, so I'm going to use this piece. And the hole in the middle is for the bearing. Bearing goes in there, and it's a slight press fit. You don't need much. I could put a little of that sticky stuff on there that they sell. Loctite sells it. But anyway, yeah, this one, that was the thing about this part too. See, here is nice and snug. And what happens is that I held this in a collet, and I knew this was going to happen. When I squeeze that collet down, it's going to make this diameter smaller, which is going to make this smaller. So when I bore it, when I release it from the collet, it's going to grow, and it's going to make this ID bigger. So I kept taking it out and putting it in to check that fit in the back. But I think what happened was that the boring bar that I used for this, it dug in the back. It kind of pushed a little bit and made it, it's snug, nice and snug here, but it's a little bit looser on this side. Actually, it's quite free, but anyway, what I decided to do was to go with this block. Now, I got my adjustment slot here, so I could, actually it goes like that. So I could put the belt on, then snug it up when it gets over here. And this is my height that I'm looking for. I'm not sure what the height is yet because I haven't got the part. But what's going to happen is I'm going to hollow this out and then put the board with the little magnet receiver inside here. I want to hollow this out, then eventually put a cover on here so it's all enclosed with the prongs or the wires sticking out, and then maybe put a little silicone on there or something. But I haven't got the parts, so I don't know where the depth on this is. But I made this shaft, and I had to make it 2 pieces. See, I couldn't put a screw in the back. I had to put the screw actually into the part because that's where the magnet's going to go, on the back end of here. This is just a saw cut because I don't know what the depth is because I don't have the part. But I know it's going to be, there's going to be a circle in here, probably a 1/4 inch diameter, probably down to here somewhere. It's going to hold that. And I made these little thrust, well, there's thrust bushings. They're not bearings, they're bushings. And what happens is that this bearing fits onto here, and because this is steel, I didn't want the steel riding on the aluminum, so I made these little thrust bushings, I guess you would call it. So what's going to happen here is that when I tighten this down, see, that still spins. I don't know if you can see that. but there's like no forward or backward movement in there. It's just rotational movement, and that's going to fit inside of here. I made this one a little bit tighter, actually a lot tighter than probably what I should have. But you don't want to make it too tight to where it clamps down on that bearing and keeps it from rotating. So I put a little flat on there for this set screw. So what's going to happen here is that this is going to be using the existing holes that I had from my original cover. I'm just going to put 2 in here. Yeah, that's where my cat got me. So this is going to mount here. That's going to slide back and forth. Trying to find some screws for that. Yeah, these are 632. These are 832, and around here are 632. So that's going to be like that. And this gets mounted on here. This gets mounted on here. Got my adjustment there. So I put the belt on. Now this thread here, I thought about making a nut for it, but I'll just use the original nut that came with the unit. So that gets mounted like that. Now these screws aren't the right length, and I didn't break the, I don't want them going through hitting the pulley, so I'm leaving them loose. I got different screws somewhere. Maybe here's a shorter one. No, that's too small. I don't know where it is. I have to use this. Anyway, that goes like that. And as that rotates, it just rotates identical to the original. So the shaft that's in the back, so the shaft, like I said, is going to get, that's where the bearing's going to go. Going to face that off and put a little circle in there. I think the bearing's 6mm. I'm not sure. So the bearing's going to go in there. Then the plate, I'm going to face that down, and the plate is going to fit on here. And then I got to set the gap between the magnet and the plate by taking this down. And if I don't take this down, I can always build a cover on top of here to enclose it, because I don't want it exposed. And once I set that gap, everything's going to move together. I can't imagine why I would want to take this on and off. This, once you set this, nothing should change on it. Anyway, that's what I come up with so far. And of course, there's going to be a cover on here. And that's going to be the fun part. So the cover still has to have a hole like this. So what I imagine this cover to look like is going to look similar to this, except I got bigger diameters inside of here now than what I had before. And then it's going to fit over here. Going to fit all the way around this thing. Of course, that'll be taut, but so I got to have an opening on that side, and then a closed on this side, and it's all going to be hollow inside, and it's going to be quite the thing to make. So I thought about it, and I thought, well, I could machine that, but there's going to be a lot of time in it, because some of it's going to have to be 3D'd, this and that. And I thought, well, it'd be a good excuse to buy that 3D printer I've been looking at. So I think that's what I'm going to do, because a lot of these parts, I'm making, and I could be 3D printing these things. So I think that's what I'm going to do. And I have to design it. I have to come up with a model of it. Now I'm imagining right now it's going to look something like the primary cover on a Harley motorcycle. And you got the big end here, and you got a little smaller end here, and going to have to put a hole through it there. But I mean, I don't want to make it just square. I want to make it so it looks nice, you know. But it's got to be functional too. It's got to keep the chips out. Because you don't want any chips getting in that belt, throwing your encoder off. And as far as the electronics and the code and making it all work, that's another story. But nevertheless, I mean, these components that I'm making here have to be here. They have to be made. And as far as the rest of it, you know, the electronics and what have you, you know, that's actually the cheap part. You know, you buy this for $6 and buy that for, you know, $8 or whatever, and that's really the cheap part. You know, the time involved parts are making this stuff. The electronics, you just bolt it on there and you plug it in, and you know, it works or it doesn't work. And if you fry a part because you did something wrong, you spend $8, you buy another one, you know. Not like a big deal. But this is the plan. So we're going with it. Try to get this thing a lot more reliable than what it was. So when we get something new going on here, we'll give you another update. All right. Talk to you later. Bye.